Today we're going to look at sections 7.1a and 7.2, graphing exponential growth and decay. Our objectives are to be able to graph exponential growth and decay functions with and without shifts. Our standard form of an exponential growth or decay function looks like this. F of x equals a times b to the x minus c power plus d. And you're going to see a lot of the same letters that we used before with our shifts when we did our transformations. And in this is an exponential graph because we have a base to an exponent. That's how we can tell. And if our base value, if the absolute value of that is greater than 1, it's called exponential growth, because if we're multiplying by a number greater than 1, it's going to get bigger and bigger and bigger. And if our absolute value of b is less than 1, okay, so think of a fraction, a proper fraction, we're going to get an exponential decay, because if you're multiplying by a number less than 1, the value is going to get smaller and smaller and smaller. If you notice, it never equals 1, because if you multiply anything by 1, doesn't matter what the power of 1 is, it's going to stay the same. So that does not give us an exponential graph. We're going to go through 6 examples. Our first example, f of x equals 2 to the x power. Now this is a very basic one, and sometimes the basic ones are harder to see all the different parts. So if I go through this, the a value is actually 1, because this is, if I rewrite it in standard form, which it is, but with all the values written in, the a, the b, the c, and the d, this is what it would look like. Okay, so I can get a lot of information from this. I know the a value is 1. I know my base, or b, is 2, which is greater than 1, so this is a growth problem. And because c and d are 0, that means we have no shifts. So how do we actually use this information to help us graph? Before I get to using this as kind of a shortcut to understand how to graph this, let's just go back to our basic 2 to the x. Now if you don't know what a graph looks like, you can always just take x values, input it in, do the algebra, and get an output. Okay, input your domain, get out your range. So that's what I'm going to do first. So if I put in a 0, 2 to the 0 power, anything to the 0 power is 1. If I put in a 1, 2 to the first power is 2. Just put in a 2, 2 squared is 4. Next, 2 cubed is 8. 2 to the 4th power is 16, so it's off my graph, so I'm not going to worry about it. But can I use a negative number? So let's just do that over here. 2 to the negative 1. 2, say, to the negative 2. If you remember what the negative exponent does, it just moves it. Since this is a numerator, it now moves it down to the denominator. This is in the numerator, it moves it down to the denominator. So when I put in a negative 1, I get 1/2. When I put in a negative 2, I get 1/4. Okay? The next one would be 1/8, and then 1/16, and then 1/32. These numbers are just going to get tinier and tinier. It's actually the same values we get on the positive side. They just happen to be in the denominator now. So what I'm going to do is just connect my points. So what I'm going to get is this curve that gets closer and closer to the value of 0, but never actually attains 0. But you're never going to be able to tell the difference. So what we do to show that it gets really, really, really close to our y equals 0, but never actually attains it, is we put this dotted line. This dotted line is called an asymptote. And it's a way of showing that this line gets so close to our y equals 0 that we won't even be able to tell the difference. So that's why we put a dotted line. If you went out far enough, say you put in negative 1 million, 2 to the negative 1 million, it's going to be an extremely, extremely tiny, tiny number. So it's going to look like 0, but it's not going to actually be it. So that's what we do. So how could I have done this without just our plug and chug to get our points? Well, this is how I do it, and every teacher might do it a little bit differently, but I find that this helps me out a lot. I start with my base number, my a value. My a is 1, okay, and if you notice, I started 1 above my x-axis. So I'm going to put a 1 here. I'm then going to look at my b value, which is my multiplier. Every time I go 1 to the right, I'm going to double my value, because the b value is a 2. Then I'm going to double it again, it would be 4. Double it again, we get 8. And if you notice, I kind of think of this as like the AT&T bars. At the end of these values would be my points, and this would be my asymptote right down here. And if you look at the graph, this is actually what happens. If I start at 1 above, this one's 2 above, this one's 4 above, this one was 8 above, the next one would have been 16 above. If I go the opposite direction, instead of doubling going to the right, I'm going to divide by 2, or take half. I'm a half, a quarter, an eighth, and so on. And then you just connect your points. If there was a shift, As soon as I shift this first point, then I do my little bars from there. So let's go through to another example. This one is 2 times 1/4 to the x power. My a value is 2. My b value is 1/4. Because that's less than 1, this is going to be decay. And again, this would be minus 0 plus 0, so I have no shifts. So how are we going to do this? Because I don't have any shifts, I know that my asymptote isn't going to move. So I'm just going to start by drawing in this dotted line. Because again, no matter what I take an exponent to, even if I have a negative exponent, it's just going to flip it down the bottom. It doesn't make it a negative value. It just makes it a smaller number, or a larger number in this case. So now, my a value is 2. So how would this work? So that tells me that when I put in a 0, I'm going to get a 2, and I have no shifts. So I'm going to go 0 up to 2. Now, as I go to the right, I'm actually decaying or getting smaller. So that means I started with 2, and as I go to the right, I'm not going to multiply by 2 like I did last time. I'm going to multiply by 1/4. So if I take 2 times 1/4, I get 1/2. So I know as I go to the right, I get 1/2. And if I want to write again, if I take 1/4 of that, I'm going to get 1/8. But those are really tiny, so going to the right is actually harder. What happens if I go to the left? I should be getting bigger, because I decay to the right. That must mean I grow to the left. Well, if I multiplied by 1/4 going this way, I'm going to divide by 1/4 going this way. Well, we don't like to divide by fractions, so instead of dividing by 1/4, we multiply by 4. If this is 2, the number before it must have been 8. The number before that must have been 32, because if you look to the right, I keep dividing by 4 to get my next number. So I know this number is 2. The next number is 8. The next number, going backwards, would be 32, which is off my graph. Going to the right, I would get 1/2. Then I would get 1/8, and so on. So this one's much steeper. So my graph would look like this. And again, it's going to go towards that dotted line. And it's decaying as I go to the right. So look at our third example. All right, so this one has a little bit more involved. And if you look here, my a value is 1. I'm multiplying by 3, so it's a growth. But now I have shifts. Remember, anything with the x goes the opposite direction. So this one's going to actually go right 3 and down 8. So how's that going to change my asymptote, my dotted line? Well, normally the dotted line is right here. Okay, but now this line is going to shift right 3, but if you shift this line right 3, you're not going to be able to tell the difference. So what I can tell, though, is if I go down 8, that is going to be noticeable. Okay, so this down 8 is what I'm actually going to see. So now, if you remember from my little bars, everything we talk about comes from this asymptote. So where am I going to start? I'm going to start at 1 above my line, and as I go to the right, I'm going to multiply by 3. So that's 1. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 would be 27. I know that's going to be off my graph. What happens if I go to the left? So as I go to the right, I'm going to multiply by 3. As I go to the left, I divide by 3 or multiply by 1/3, the reciprocal. So to the left would be 1/3. So again, I start here. Normally, and you could do this a couple of different ways. Normally I would start at 1. Here's my 1. Because that's where it says I start, 1. But what I'm actually going to do is this point doesn't start at 1 because I have a shift of right 3, 1, 2, 3, and shift down 8, 1, 2, 3, 4, 5, 6, 7, 8. Now if you look at that, I'm 1 above my dotted line, just like I said I should be. Okay, so if it's easier, just think, okay, I'm starting 1 above my dotted line, I've already my shift down, and then I must have to shift right 3. Now from here, I'm going to do my points. I'm 1 above my dotted line, now I'm 3 above my dotted line, then I'm 9 above the dotted line, so here's 8, 9, then I would be 27, which is way off my graph. If I go to the left, I'm 1/3 above the dotted line, so about 1/3. I'm going to take my pen, and I'm just going to connect. Okay, I know this is going to go up really high, so I'm just going to start way up high and then go through and connect and then extend towards my asymptote. And that's what this graph looks like. It should grow as I go to the right. And again, my little bars, this is a third, 1, 3, 9, and that would be 27. In this example, I have a lot going on. My A is a -4. I can see my B is 1/2 because it's less than 1, this is going to be a decay. X plus 5 tells me I'm going to move left 5. And plus 1 tells me I'm going to go up 1. So, first thing we're going to always deal with is our asymptote. So I know that's my dotted line. It normally starts at the x-axis. So let's think about how this is going to move. I'm not going to see a left 5 with a horizontal line, but I am going to see a shift of up 1. That'll be noticeably different. So now let's think about what the little bars are going to look like. So, how does this work? Well, because it's a negative, this is actually a reflection. Okay, so now, instead of starting with my bars going up, my bars are actually going to go down from my dotted line. So let's just off to the side, do a little work. There's my dotted line. Okay, I know the first one is going to start 4 below. So that's my 4 below. As I go to the right, I know I am multiplying by 1/2 because that's my B value. So half of -4 is -2. Half of -2 is -1. Half of -1 is -1/2. If I go to the left, instead of dividing by 2, I'm going to multiply by 2. So this would be -8, and then if I kept going, -16. So again, this is a decay, because as I go right, the graph is actually getting smaller. It looks like it's going up, but it's actually getting closer to my dotted line, my asymptote. So how do we actually do that on our graph? Well, let's figure out where that first point is going to go. Normally we start at -4. So there's my -4. But how am I going to shift? I'm going to shift left 5 and up 1. So if I go left 5 and up 1, that is my new starting point. And if you notice, that point is 4 below the line, because that's what we get, that's our A value. So as I go to the right, I should be 2 below the line. So here's my line, here's 4 below, 2 below, 1 below, a half below my asymptote. If I go the other direction, this is 4, I should be 8. 1, 2, 3, 4, 5, 6, 7, 8. And I can tell 16's off my graph. And if you notice, again, this distance is from my asymptote. So what I'm going to do is connect these points. And that negative reflects it. So instead of all those points being above my dotted line, they're now above. All right, let's go to our fifth example. Again, we have another negative, so my A is -3. It's multiplying by 2, so this is a growth problem. And I'm not doing anything with the x, so this is just a shift down 2. So let's see if we can do this from the beginning. I can see my dotted line here, but I know it's going to shift down 2. So I'm just actually going to start drawing my line here, because you guys don't have the opportunity to draw and just magically move it. So instead of erasing, let's just go down 2. Alright, so how do we do the work? I know normally I would start 3 below at -3. This is where I'd normally start. My A value is -3. But I know I had to shift down 1, 2. What could you do instead of like drawing a point and then shifting it? I know I'm going to start 3 below my asymptote on my x-axis. Because I didn't shift left or right, I'm just going to go down 1, 2, 3, and I don't have to worry about a left or right shift. Or, just like I did, start at -3 and then look at your shifts and think I have to go down 2. As I go to the right, because this is growth, as I go to the right, I'm going to be multiplying by 2. So I'm going to start with my 3. As I go to the left, I'm going to be multiplying by the reciprocal, 1/2. So here's 3. As I go to the right, I'm going to double it. So here's 3 away, but I know I have to be now 6 away. If I double 6, I would be at 12 away, but that doesn't fit on my graph. But what if I go to the left? Okay. If I'm at 3, when I go to the left, I take half. Half of 3 is 1.5. Half of that would be 75%, 3/4, and then you can keep going. So now what I'm going to do is I'm going to connect the points. Get a nice smooth line. I know this is going to keep getting smaller and smaller, or closer and closer to this value of -2. And that's my graph. Just look at our last example. Okay, again, this is going back to where there's no number in front, so my a is 1. I'm multiplying by 1/3. Since it's less than 1, it's decay. And now I don't have any d value, but I'm shifting right 4. Okay, so again, I'm going to draw my asymptote. Because it's just a shift left or right, I know my line is going to stay right here at the x-axis. Okay, I'm going to start at 1, so I'm going to put a point at 1, but I know this point is going to now shift right 1, 2, 3, 4. And again, your a value is how far away from your red line or your dotted line asymptote you should be when you start. So from here, I know as I go to the right, I'm going to get 1/3 smaller. So I know I started at 1. Okay. If I go to the right, it's now going to be 1/3. And then 1/9, it's going to get smaller and smaller. So as I go to the right, I'm going to be multiplying by 1/3, which means as I go to the left, I'm going to be multiplying by its reciprocal, which is 3. Which 1 times 3 is 3. 3 times 3 is 9. So I'm 1 above. The next one to the left should be 1, 2, 3 above. The next one should be 9 above. That's all that's going to fit on my graph going this way. Going to the right, I'm at least going to attempt to do 1/3, get as close as you can. And now I know the numbers are going to get too small. And now I can connect. I like kind of thinking of it as these bars because I think it gives you a lot of power to understand exponentials. Okay, I'm multiplying exponentially. This isn't growing linear. It's not growing at the same speed. This is 3 times bigger, 3 times bigger, 3 times bigger. My differences between my heights are growing exponentially. And that's our last graph. Hopefully you feel a little bit better about graphing growth and decay functions with and without shifts.